Motion Class 9 Notes. In Class 9 Science Chapter 8 Motion, students learn to describe the motion of objects along a straight line and express such motions through simple equations and graphs. Reference point and reference frame. To describe the position of an object, we need a reference point or origin. An object may seem to be moving to one observer and stationary to another. Example: a passenger inside a bus sees the other passengers to be at rest, whereas an observer outside the bus sees the passengers to be in motion. In order to make observations easy, a convention or a common reference point or frame is needed. All objects must be in the same reference frame. Distance and displacement. The magnitude of the length covered by a moving object is called distance. It has no direction. Displacement is the shortest distance between 2 points or the distance between the starting and final positions with respect to time. It has magnitude as well as direction. Displacement can be zero, but distance cannot. Magnitude. Magnitude is the size or extent of a physical quantity. In physics, we have scalar and vector quantities. Scalar quantities are only expressed as magnitude. For example, time, distance, mass, temperature, area, volume. Vector quantities are expressed in magnitude as well as the direction of the object. For example, velocity, displacement, weight, momentum, force, acceleration, etc. Time, average speed and velocity. Time and speed. Time is the duration of an event that is expressed in seconds. Most physical phenomena occur with respect to time. It is a scalar quantity. Speed is the rate of change in distance. If a body covers a certain distance in a certain amount of time, its speed is given by speed equals distance, time. The instantaneous speed is the speed of an object at a particular moment in time. Average speed is stated as the distance covered by the object within a period of time. Average speed equals total distance traveled, total time taken. Uniform motion and non-uniform motion. When an object covers equal distances in equal intervals of time, it is in uniform motion. Examples of uniform motion: movement of the ceiling fan's blades, motion of Earth around the Sun, pendulum with equivalent amplitude on either side. When an object covers unequal distances in equal intervals of time, it is said to be in non-uniform motion. Bouncing ball, running horse, moving train. Velocity. The rate of change of displacement is velocity. It is a vector quantity. Here the direction of motion is specified. Velocity equals displacement backslash time. Instantaneous velocity is the rate of change of position for a time interval which is very small, i.e. almost zero. In more simple words, the velocity of an object at a given instant of time is known as instantaneous velocity. Average velocity is defined as the displacement, x, divided by the time intervals, t, in which the displacement occurs. Begin array L average velocity equals frac initial velocity plus final velocity to end array average velocity instantaneous velocity. For more information on average speed and velocity, watch the below video. To know more about average speed and average velocity, visit here. Acceleration. The rate of change of velocity is called acceleration. It is a vector quantity. In non-uniform motion, velocity varies with time, i.e., the change in velocity is not zero. It is denoted by A. Acceleration equals change in velocity, time. Where t, time taken, v, final velocity, and u, initial velocity. Motion visualized. Distance time graph. Distance time graphs show the change in the position of an object with respect to time. Linear variation equals uniform motion and nonlinear variations imply non-uniform motion. The slope gives us speed. OA implies uniform motion with constant speed as the slope is constant. AB implies the body is at rest as the slope is zero. B to C is a non-uniform motion. Velocity time graph. Velocity time graphs show the change in velocity with respect to time. Slope gives acceleration. The area under the curve gives displacement. Line parallel to x-axis implies constant velocity. OA equals constant acceleration, AB equals constant velocity, BC equals constant retardation. Equations of motion. The motion of an object moving at uniform acceleration can be described with the help of three equations, namely I, b equals u plus at 2v2u2 equals 2s 3, s equals a plus, half at 2. Where u is the initial velocity, v is the final velocity, t is the time, a is the acceleration, and s is the displacement. Derivation of velocity-time relation by graphical method. A body starts with some initial non-zero velocity a and goes to b with constant acceleration a. From the graph BD equals v, final velocity, dc equals u, initial velocity, equation 1. BD equals BC dc. Equation 2.